Hello class! Today we're looking at 7-3, volumes of prisms and cylinders on page 263. To find the volumes of prisms and cylinders is what we're going to learn today. Some new vocabulary we'll need to know is volume and cubic unit. So why do we want to know this? Many storage silos, that's what these are called right here, are shaped like cylinders. You can use volume formulas to find the amount of storage space inside a figure like a silo. The volume of a three-dimensional figure in the number of cubic units needed to fill the space inside the figure. A cubic unit is a cube with edges 1 unit long. A cubic centimeter is a cube with inches 1 centimeter long. So this is an example of a cubic centimeter. Consider filling the rectangle prism below with cubic centimeters. The bottom layer of the prism contains 10 by 4 or 40 cubes. So see, here's 4 this way, 10 this way. So there's 40 cubes on that bottom layer. Well, there are 3 layers. 1, 2, 3. So you take the 40, 4 times 10, and multiply that by the 3, and that's going to give you 120. The volume of a prism is 120 centimeters cubed. So now when we're talking about volume, right, with area we squared it, volume we are going to cube it, 120 centimeters cubed. The previous calculations of volume suggest the following formula. Volume of a rectangular prism. This is what you want to know. The volume equals the area of the base times the height. So to find the area of the base, you've got to multiply the length times the width, and that gives you the area of the base. So in other words, if you were to just multiply length times width times height, you will get the volume. Find the volume of a rectangular prism. Mr. Cho is building a craft box like the one shown on the right. What is the volume of the craft box in cubic inches? So here's our formula. Volume equals length times width times height. Length times width times height. 3 times 4 times 5 equals 60. The volume of the craft box is 60 cubic inches. If the height of the prism above is doubled, what is the volume? Take a second and try to work that out on your own. Once you have the answer, come on back. So this is asking if the height of the prism is doubled. So the base and the width, the length and the width is going to stay the same, and this is going to become twice as tall. That's a terrible drawing. So if this is 5, it's going to actually be twice as tall, so 5. So that means this is going to be 10. So your equation is going to be length times width times height, which equals 3 times 4 times 10, which equals 120 cubic inches. Inches cubed. So another way to look at it is because it's just one length doubled, the height is just doubled, you could have taken 60 and multiplied by 2, which also gives you 120 inches cubed. Okay, the volume formulas for rectangles and triangles are similar. Here's another one. You want to write this down. The volume is the area of the base. So we have to remember the area of the base is the area of a triangle, which is going to be the length times the height times 1/2, right? Because it's going in a square and then half of that is the triangle. So the area of the base times the height. So the base area times height. So let's use this as an example. Find the volume of a triangular prism. So here's our formula. The volume equals the base area times the height. So to find the base area, we're doing 3 times 4 equals 12. Divide by 2, or times 1/2. So that's going to equal 6. So now we have that base is 6 times the height is 6. 6 times 6 is 36. The volume of the triangular prism is 36 centimeters cubed. So your turn. If the height of the prism above is doubled, what is the volume? See if you can figure that out. Press pause and then come back to me. Okay, so much like the one above, we can look and see. We know that the base area was the 4 times 3. That's going to stay the same. 4 times 3 is 12. Divided by 2 is 6. So we have 6 times, and now what it told us is the height, which this is what we're using as the height, is doubled. So that means it's twice as long. So 6 plus 6 is 12. So that's going to equal 12 there. 6 times 12 is going to equal 72 centimeters cubed. And so another way to look at it, when they do things like this, if the height of the prism above is doubled, all we have to do is double what we did before. 36 times 2 is also 72 centimeters cubed. Either way is a way that you can use to come up with the correct answer. The volume formula for a cylinder is also similar to the volume formula of a prism. So once again, take notes. This is what you will need to know. The volume equals the area of the base. So, right, we have to be able to figure out the area of a circle times the height. So the base times the height. So if you put that into an equation, you can also see that it's pi r squared times the height. Okay, let's try to use it in an example. Find the volume of a cylinder. Estimate the volume of the cylinder paint can. Then find the volume to the nearest cubic unit. So our radius, half the width of the diameter would be the whole one, is 4 inches. And the height is 9 inches. So if we put that into the equation, we can see, oh, and this says estimate. So when we estimate, we can just use 3 as pi, because otherwise, right, we know that pi equals 3.14. But if it's estimating, we're just going to round it to the nearest whole number. So 3 times 4 squared times 9. 4 squared means 4 times 4, and that equals 16. 16 times 3 is going to equal 48. And so they went ahead and rounded it up to 50. and did 50 times 9 is about 450. If you wanted to come up with the exact, you would do the radius squared, so 4 times 4 equals 16 times pi 3.14 times 9. So that answer is 452.16. So 450 is very close. That's a good estimate. So let's look, the calculations. Oh, so look it. I jumped right ahead of myself. They went ahead and did what I just talked about. Multiplying it out, 452. The calculated volume is about 452 inches cubed. Check for reasonableness. The calculated volume is close to the estimated volume, so the answer is reasonable. If our estimated answer was 1,050 and the answer we came up when we calculated it was 452, we'd know there'd be a problem. Okay, so quick check. Go ahead and see if you can figure this out, and then come back to me once you have an answer. Okay, so estimate the volume. So estimate first, then find the volume to the nearest cubic centimeter. So our reasoning, suppose you estimate using 20 for 4 times 4 instead of 16 in example 3. Will your estimate be reasonable? Okay, so let's just break this down from what we know. So we first need to know the radius. Well, guess what? It doesn't give us the radius. It gives us the diameter, the entire length. The radius is half of that. So what is half of 18? 9. So we are going to do 9. So we're going to go 3 for pi because we're estimating. We're going to do the little wiggly equals. 3 times 9 squared times the length is going to be 24. So when we estimate that, so first 9 times 9, 81 times 24 times 3 is going to be 5,832. So our estimate is 5,832 centimeters cubed. So now they want us to find it to the nearest cubic centimeter. So instead of rounding this time, let's do the exact. So we are going to do the same things here. I guess you could have used 10 as the estimated here. 10 times 10 was 100 times 24 is 2,400 times 3 is going to be about 7,200. That's where rounding can be difficult because it depends on how far you are using your rounding. Sorry, that writing was atrocious. I've got to try again. Okay, so then using more of the exact, so we go 9 times 9 times 24 times pi 3.14 is going to equal 6,104.16 centimeters cubed. Notice how I did the straight equal signs there. So really, our estimates are right in there. We also could have estimated 25 instead of 24, rounded that up to 25. which probably would have helped get us a little bit closer. So now the next question asks, suppose you estimated using 20 for 4 times 4 instead of 16. In example 3, will your estimate be reasonable? So up here in example 3, we did 4 times 4 equals 16. So instead of that, they're saying, what if we did instead of 16, we used 20? So if that was the case, then we would have 3 times 20 times 9. And if we multiply that out, 3 times 20 times 9, it's going to equal 540. And our estimate before was 450, and the calculations was 452. So will that make it be reasonable? It'll be a little too large. So to wrap things up, what is volume for a three-dimensional figure? It's the number of cubic units needed to fill the space inside the figure. How do you find the volume of a rectangle? Use the volume equals length times width times height and write it with the units cubed. How do you find the volume of a cylinder? Use the formula volume equals pi r squared times the height, where r is the radius and h is the height of the cylinder. Write the units cubed. I went ahead and wrote those two formulas at the top of the page here. If you have not already put those on a piece of paper somewhere, go ahead and do that so that you can remember that for the rest of your lesson. So let's do the first two together. The number of cubic units needed to fill the space inside a three-dimensional figure is called the volume. How does the volume of a cylinder change if the height is doubled? So we had gone through that. So this should be an answer that comes right to your head. A, it does not change. B, it doubles. 3, it quadruples. D, it halves. Remember, we just said you could multiply it by 2, therefore it doubles. B is your answer. Go ahead and for your homework, please work through numbers 3 through 17. So number 3 through 17. Very good. Have a great day. Bye.